We're going to look at a process called completing the square. This process should be able to help us to be able to take things that are in a non-factorable form, in standard form, and turn it over to vertex form. You and I already learned a technique for solving in vertex form. So if you look at the one I've got here, I've got x squared minus 4x plus 2. If we tried to factor that, we'd be looking for two numbers that multiply to 2 but add to -4. There aren't any. So what I'm going to try and show you is how to go from the one form to the lower form, because I think we can solve that. And the method we do to do that is called completing the square. Let me show you how to do that. To understand how to complete a square, and these are completed squares, maybe I need to make sure you understand that. You see how this whole term is all squared and this whole term is all squared? Those are what are called the completed squares. So to find out how to make those, we're going to learn how to undo them. So let's quickly multiply these out. And again, that's what this means to square it. We get x squared plus 3x plus 3x plus 9. And I get x squared plus 6x plus 9. Let's quickly do this one, and we'll see with these two if we can get a pattern. I get x squared minus 5x plus 25, x squared minus 10x plus 25. Let's show you some very important things. First of all, the last term is always a perfect square, because you're always going to be multiplying, like the 3 and the 3, or the -5 and the -5. The next thing to notice is that the middle term, of course, was added together to obtain it. Now, an even more powerful thing would be to connect, because the numbers are the same, we're looking for two numbers that add to this but multiply to that. And what we learn is that because this was made by adding the same thing twice, if we divide it by 2, we get 3. And 3 squared is 9. And notice that same pattern happens here. If we take -10 and divide it by 2, we get -5. And if -5 squared equals 25. This is a way for us to learn how to work backwards, that these would be the perfect squares that made this. Let me show you in reverse now. Once again, by seeing patterns here, I know that the middle term is done by adding them together and the end term is done by multiplying them. The middle term is made by adding the two numbers, in this case are the same, and the other term is C is made by multiplying. Middle term is made by adding, and then the C term is made by multiplying. Again, I notice that if I take half of this, I get 2. And 2 squared is 4. If I take half of this, I get -6, and if I square it, I get 36. If I take half of this, I get 8, and 8 squared is 64. So this helps me to, again, knowing a pattern, reverse it backwards. Now we'll show you how to use it for solving. This is a pretty cool technique. So let's just say that we are unable to figure this out through factoring. This one actually can be factored, but let's say we just didn't know that it could be factored. Or we were told to use the completing the square technique. Let me show you how this works. And again, I think this is kind of cool. What I'm going to do is I'm going to leave this part here, create a little space, and I'm going to move my 8 to the other side. Now the reason I'm doing that is because I know it's not a perfect square. How do I know that? Well, half of 6 is 3, and 3 squared is 9, not 8. So I know it's not a perfect square, but what I'm going to do is create one, or complete one. So I used my little algorithm that we just talked about. Half of this is 3, and 3 squared would be 9. So I'm going to put a 9 there. I'm also going to put it on the other side of the equation to keep things balanced. Remember, anytime you create something to add to one side, you must add it to the other side as well. Now, why did I do that? Well, take a look. I've created a perfect square. I have x plus 3 squared equals, over here, let's see what that says, is 1. And now, do you see how, because it's in this format, I can continue the solving process? So I could take the square root of both sides. This is x plus 3 squared equals plus or minus the square root of 1. X plus 3 equals plus or minus 1. And x equals negative 3 plus or minus 1. So our two answers would be negative 4 and negative 2 would be the solutions to this problem. But by completing it, again, this idea of by completing the square, putting it in this format, it made it quite simple for us to solve. Let me do another one. So here's another example where we can recognize that this is not a perfect square method, because half of 8 would be 4 and 4 squared would be 16. So what we can do is we can solve it using the completing the square technique. So again, I am going to create a little space here. I'm going to move my 12 to the other side, create a little space here. And half of 8 is 4. 4 squared would be 16 to both sides. Therefore, I get x squared plus 8x plus 16 equaling, what do we got over there, 4. This would become x plus 4 all squared equals 4. And again, this is in a method and a time and a place that you and I can take the square root of both sides. And I get x plus 4 equals plus or minus 2. I can move the 4 over to the other side to get plus or minus 2. And my two answers would be negative 6 and also negative 2 would be those two values. Now again, I could have factored this just normal using my own factoring techniques. I'm just using these examples to teach you a method. Let me again show you one more quick one. Now this one looks scary right away because of the fraction, but actually I've put that there hopefully to make this an easier question. But we definitely recognize an issue right away, that this is an odd number. So if you divide by that value, you're going to not get a number like 2 or 4, but you'll get like negative 3 halves. So these guys are trickier because of the fraction. But let's go through the same process. So let's move our value over to the other side and leave a little space. Now when you divide negative 3 by 2, this is what you get. And when you square that, you get 9/4. So I'm going to add 9/4 to both sides. And again, things are a little messier because of this. But basically, our value that goes in the perfect square would be the negative 3 halves. And over here, we get 8/4, which comes out nicely to be 2. That was why I set this one up the way I did, is because at this stage things get a little bit easier. So let's keep going here. We would take the square root of both sides, and what we get is x minus 1.5. Let's change it to 1.5. That's what 3 halves is. Equals plus or minus the square root of 2. And then our answer would be 1.5 plus the square root of 2 and minus the square root of 2. Now this is definitely messier. Be patient with it. Let me just back up and kind of go through it again a little bit. So instead of being even, it was an odd number. So when we divide it by 2, we got a fraction, and then we squared it. When you square a fraction, you see you squared the top and the bottom. And I added that to both sides. So I had it on this side and on this side. Now the whole reason we did that was so that we could simplify it in completed the square format like this. And then we just followed the same kind of pattern. Tricky for sure. Follow along though, it'll work out for you.